Hi everyone, welcome to this new lecture of Fluid Mechanics. In this lecture, we'll discuss a new concept regarding the model analysis. So up to now, we have discussed about the dimensional analysis and methods of dimensional analysis, and different methods are there. We have seen that Rayleigh method and Buckingham-Page theorem. Now here we'll discuss about the model analysis. So model analysis actually it's nothing but this is a prediction, or we can do some analysis of prediction. So what kind of prediction or what kind of analysis? So before going to test the performance of any kind of instrument or any kind of structures or any kind of machines, we can say, so we need to do some kind of analysis by preparing some kind of model. Okay, so we can say, as I told you, that we need to do some test of that. So what kind of test? Suppose we will consider some kind of structures. If you consider some hydraulic structures, so in the structures you can consider what kind of structures are there. Suppose some kind of dams are there. Okay, in the civil you can see some kind of dams will be there, and some kind of spillways also all will be there. So before going to these structures, actually we need to before going to the original structure, or before going to construct the hydraulic structure of like this, we need to do some kind of model of that, or we can prepare some kind of prototype. Then we can go for some testing in that, and we can visualize and we can identify before going to the actual construction. Similarly, if you consider some kind of hydraulic machines, suppose in the hydraulic machines we know that we have pumps are there, and we have turbines are there. So if you consider the turbine and pump, here also similarly, before going to develop or design or manufacture these pumps and turbines, we can do some kind of performance prediction or performance testing of this by creating some kind of model, or you can say prototype. So here in the model analysis, again it is a simple one. I can say first, what is actually model? So model can be considered like it in a small replica of actual structure. So this one we can write, this is a small replica of, you can say, actual structure. This is a small replica of actual structure, or we can say any kind of, or slash I can write machine, because two things I have told there. So let consider this structure or machine. So the actual structure of a machine, again, what is prototype? Next is prototype. Next is prototype. So prototype is nothing but this is the actual structure, or actual structure or machine is called prototype. Okay, so that if you want to more the difference between this model and prototype, we can take a small example. Like suppose we are going to design a car, and before manufacturing a car, we need to do some kind of analysis in that. So first of all, we need to do some design, and after designing we need to create some kind of models. Okay, so once you create the model, then after that, if it is okay everywhere, all the sides are okay, and the inclination is good, then doors are well, and everything need to be checked by the R&D committee members. So after this, we can go for the prototype development. So that is, you can say before prototyping, we need to do some kind of model. Now here again, one more point I can say, that model can be like this one. In model, it can be like analytical. It can be says that this is analytical, or I can say this is a mathematical one, or you can say this is also can be called as a physical one also, or also you can say it is called as a mathematical, or we can say conceptual. So these are the things can be considered under the model type. But prototype, we need to develop some kind of structure, actual structure, we can say, before going to the original one, or before going to the real development of a structure or machine, we need to do some kind of prototype. Okay, so that is prototype. Similarly, we can say in the study of models, actually the actual machine is called, or actual analysis is called, model analysis. So one more point you can define here. So the study of models, we can say what is model analysis. So we can say the study of models, the study of models of actual machines, of actual machines is called model analysis, is called model analysis. Okay, and here why this model analysis is actually required. Okay, as I told you, difference of these models and prototypes and why it is required. That means the model analysis is actually an experimental method of finding the solution of difficult complex problems, you can say. Complex, suppose any kind of complex problem will be there. So if you do some kind of model analysis, then we can say before going to the experimental method, we can do some kind of solution for the complex problems. So it can be called as the model analysis is actually in an experimental method to find the solution of a complex problems. Okay, any kind of complex problems can be taken. So for this, actually some advantages are there in this model analysis. We have some advantages in the model analysis. Okay, so you can say we can easily identify, as I told you, we can easily identify the performance of a, we can easily identify the performance of a structure or machine, structure or machine, that can be calculated or identified before going for the actual manufacturing or actual construction. So that can be predicted before. So performance of a structure can be identified. Okay, can be identified priorly. So initially we can identify the difference of or we can identify the performance of this message. So again, with the help of dimensional analysis, also with the help of dimensional analysis, also we can find out the relationship between the different variables, can able to identify the, these are the some points are coming under the advantages. Identify the relationship between different variables. We already have discussed what are the variables are there in our dimension analysis. So we can identify the relationship between different variables. Okay, which is involved in the flow analysis, which is involved in the flow analysis, or any kind of concept. If you consider in that what are the variables are involved, we can identify that one. So the relationship can be also testing for the model. Okay, so this is one more advantages. Similarly, one more advantage is there. So you can see after designing the model, the alternative design can be also predicted. So once you created one model, so what will be the alternative, or what are the other options are there, so that also can be predicted. So we can write one more, alternative design also can be estimated, or you can say predicted. Alternative design can be also predicted with the help of model testing. With the help of model testing. because once you create a model, then we are going to test for this model, or we are going to performance of this model. So similarly, some alternative designs also can be made by changing this model, and we can go for the other testing. So that will be help you for economically. So that will be help for economically, and also we can say the safe design also, economical and safe. And we can say the final structure, you can go for a conclusion. If you go for directly some kind of construction or manufacturing without any kind of testing, then it will be dangerous. That means it is going to be more costly. If suppose some fractures came or some kind of changes required, then total systems need to be changed for that. So this is one of the reasons. Similarly, one more point can be mentioned here, that the test performed for the model, you can say that can be obtained, or you can be taken in initial case, okay, which will be give you the performance of the prototype. Okay, once the similarity between the if a complete similarity exists between the model and the prototype, that means when you create the model and after suppose you are going to for the prototype, when you create the model and after suppose you are going for the prototype, if both things are similar, then we can find out the best solution from that. We can find out the best solution from this model and prototype. From the you can say from the testing or from the performance. So model can be converted into prototype, then we can find out the best solution from the prototype if we can say if both are similar. If some kind of differences came between the model and the prototype, then again we need to check it where the differences are there and why their differences arise there. So this kind of analysis can be done priorly before going to the actual construction or manufacturing. So this is the importance of the model analysis in the fluid structure especially. So this is also one important part in the fluids. So I hope you understand this concept of this model analysis. This is very simple one. That much difficult is not there. The few terms are there which you need to be focused. So I hope you understand. If you are having doubt, you can give a comment on the comment box. Thank you.